All right, let's look at 5.1 part 2. So a quick review first before we look at the ambiguous case. Let's go over our other videos we talked about when we're using our law of sines and we have two given angles. Whether it's angle, side, angle, 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 side. My picture here is angle, side in between my other angle. That's this version. Either case, no matter what, find the third angle. Once you find that third angle, you create your law of sines, create your triple proportion. So you can solve for B, that's opposite of angle A, and you can solve for C, opposite of C. So 43 over the sine of 99 degrees goes in the middle of our triple proportion. Put your B and C on the outsides. And again, it doesn't matter which one it is, just make sure you put the right angle, angle B, sine of angle B, in the denominator under the B, and angle C, sine of 29 degrees, underneath the C. And we're going to create the proportion on the left. Cross multiply the two you can. Divide by the third. 43 times the sine of 52 degrees divided by the sine of 99. Perfect. That's your calculator entry. You want to show that again? Type it in the calculator, 34.3 centimeters. Now remember, the reason for doing this is going to make your next proportion quick and easy to solve, because all we have to do is change out the 52 degrees and replace it with the 29 degrees, both in the writing and your calculator entry. So remember, you're sitting here with your cursor on your calculator, the line down here. Just hit second enter. This statement shows up again. Your cursor's right here. Left arrow over, change 52 to 29. You don't have to type everything in. Your cursor is sitting here at the parentheses. Just hit enter. You get 21.1 centimeters. All right, remember those quick and easy steps. All right, now for the ugly part. The side-side angle, which I'm going to call angle side-side. I am not going to be politically correct. Two sides and one angle not included between the sides is the angle side-side. One of the reasons I prefer that, because that's the way I want to draw it. It makes sense drawing it with the angle always in the lower left-hand corner. So when I work with my angle side-side, you're going to have multiple possibilities. And that's why we call this an ambiguous case, because we're not sure which one we have. So we have to go through a testing process. The big test is as follows. The angle that you're given and the side opposite the angle you're given. Notice that these are darker, bolder circles. Those are the key. Find that side and compare it to the other given side. All right. If A is less than B, slow down. Whenever A is less than B, you must solve for the height of this triangle. So this right triangle, that proposed right triangle, sine of A is equal to opposite H over B. We multiply the B to the sine of A, and we find our H. If side A is still smaller than H, then there is no triangle. There's no way that this side can touch the base. That line does exist. It's there. What we don't know is how big it is. So that's why it's dashed. Now, how do we get one triangle? Well, this comes in two different cases. So hear me out. If you're given let me put it this way, for our ambiguous case, all right, again, these are oblique triangles. There's no right triangles in existence. All right, again, given angle, side opposite the given angle. If this side is now bigger than B, now it reaches the base. You have one triangle. You do not have to solve for the height. That's why it's an or here, not an and. There's two ways to get exactly one triangle. This is the one we'll predominantly see in this chapter. I included this one because there's that 1% chance the author might be sneaky All right, and say, okay, A is less than B. So it's this test. I'm testing right here. A is less than B. I find the height. And I notice, hey, wait a minute. The side opposite my given angle and the height are exactly the same. If that happens, you have a right triangle. No, I don't see that happening because chapter 4 was all of our right triangles. I believe you're predominantly going to see A is greater than B. All right. Option 3. A is still less than B. That's what we're looking for. Again, whenever A is less than B, you have to find the height. Whenever A is less than B, you're finding the height, whether A is less than the height, A is equal to the height, or now A is greater than the height. In all 3 cases, whenever A is less than B, the side opposite the given angle is less than the other given side, you must find the height. And so now, if the A, the side opposite the given angle, is greater than the height, you have 2 triangles, which means, well, think about this point here at B has not yet decided where it's going to touch. So I'm swinging down. Well, I can hit here, or I can lift it up a little bit, slide it over to here, and touch that line here. Remember, that's an imaginary line. It hasn't been drawn in yet. So that gives me 2 possible points, or 2 possible triangles. So A is less than B. I solve for the height. And A is greater than B. Or another way you can say this statement up here is you could say, all right, A is less than B, but the height is less than both A and B. These 2 are the same. I kind of prefer this one here because the emphasis is on always A is less than B. Go find the height, then decide which comparison you have. Now, because you have 2 triangles, we have to solve for both. So there's 2 triangles here. There's triangle A, B, C. That's the outer triangle. All right, and so here's my C, side C that I got to find from A to B. So if I need to find C, B to A, that's this angle. A, C, all of them, the whole big thing to B, and side C. The second triangle you need to find is A, B prime, C prime. C prime is up here, but I put it inside this tiny little angle here. All right, so now you got to find that small tiny angle, this B prime angle here, and C prime, this short little segment here. Now, while we're here talking about this, and again, I'll show this again, this triangle right here, A and A, these 2 are the same sides. This is an isosceles triangle, which means this angle and this angle are congruent. So if you want to put congruent arcs in there, you can. I'm going to demonstrate this in one of the example problems so you'll see it. But B prime is this obtuse angle. B prime will always be obtuse. B prime and B are supplement angles. If this angle is congruent to this angle, and then this angle is supplement to B prime, then B prime has to be supplement to this angle over here. I know, I'm bringing back your sophomore geometry. Gotta love it. All right,